Welcome to Science in the Field, the show where we interview scientists who are outstanding in their own fields, like I am right at this moment. On today's show, we have a dynamic duo of massive objects and accretion, Annabelle and Marigold. These two have been instrumental in paving the way for understanding how massive objects can consume so much material, such as black holes and everything in between. These two have played major roles in things like the Event Horizon Telescope, which have had incredible achievements to date. So let's get into interviewing them and learn a little bit about accretion and black holes. I'm joined today by Annabelle and Marigold, both experts in massive objects and accreting matter in the universe. So I'll start out by asking them a very quick question. What is accretion used for in the universe? Right, so pretty much everything in the universe has a process that involves accretion. From the formation of stars, to galaxies, planets, the destruction of stars, and even massive objects like black holes and active galactic nuclei sitting at the center of galaxies. Now, on the topic of black holes, people often think that black holes just suck in everything around them, like an enormous pig trying to gobble up everything in sight. Is this view of black holes accurate? So I see. Black holes don't necessarily just consume everything around them. They can have objects orbit around them in stable orbits, just like the Earth orbits the Sun. Well then, how does material fall into black holes? Right, so it's the particles in something called an accretion disk orbiting the black hole, which causes things to bump together and fall into the black hole. Is that a correct understanding? You know, I'm something of a scientist myself, and I discovered a Dwarf Nova in the Kepler data recently, which was visible for 30 days because the accretion disk... Yeah? Yeah, that's right. So the accretion disks can get very bright. So what causes them to get so bright? So it's the... what do you want? So it's the material all in the accretion disk that's bumping around, which causes the accretion disk to get so incredibly bright. In my case, the accretion disk grew nearly 2,000 times brighter over the course of only a couple of hours. So it's an incredibly interesting time for black holes at the moment, with the announcement a year ago of the image of a black hole taken by the Event Horizon Telescope in M87. How has this discovery of, or this image, changed the interpretation of black holes? Right, so the most profound impact was that it showed that general relativity provided an accurate explanation of what we saw in the image. The black hole itself was pretty much a rotating Kerr black hole, which you could get a solution for from general relativity. Now that's incredible that such a theory is still standing up to modern experiments after nearly 100, or after over 100 years. The Event Horizon Telescope has also released some new data which shows a jet being formed in the center of the quasar 3C279. What has this data shown us, which is fairly unique and not been seen before? Wow, so this incredibly close view of this quasar, thanks to the Event Horizon Telescope, has shown us how these jets are being formed and new things like instabilities and turbulence that occur within the jet itself. That's remarkable. So of course this is just the beginning of the Event Horizon Telescope. What more do you hope to see from it in the future? Yeah, of course, we're still waiting with bated breath about the image of the black hole at the center of our galaxy, Sagittarius A star. And hopefully we'll get an image sometime in the near future as they collect more data going forward. Anyway, Annabelle, Marigold, it's been a pleasure having you on the show today. I wish you the very best in understanding how massive objects accumulate so much mass and consume so much material. Oh, Jesus Christ. Good pig.